Hello, Olathe West. Today's math lesson for ACT Prep will be dealing with exponents. A couple things to think about this lesson is want to make sure you've got something to write with, some paper. Graphing calculator would be preferred. And then the two most important pieces are these willingness to learn and a positive attitude, right? Like you should be thinking to yourself, hey, here's a way I can try to get some of these questions right on that test. Because many of you took some form of an ACT exam in October, whether it be the pre-ACT or the in-house practice ACT. Want to take those lessons learned from there and move forward and try to get better and better with this type of material. Today's is more of an algebra lesson, right? It's going to be dealing with exponents and exponent rules. First thing I need you to do is to copy down all of these exponent rules. You may not remember them or even seen them before. Hopefully you have. A couple things as we go through these, as you're writing them down, is that whenever you're multiplying values with an exponent, you add the exponents. Now, the important thing to remember here is that the base is the same value, okay? If we've got a power raised to a power like we have here, we're going to multiply those powers. So here we are adding the powers, here we are multiplying the powers. And then if we are dividing, okay, dividing means we subtract the powers. And I kind of think of that divide sign as a very large minus sign to kind of help myself out. Now notice you could do it dividing like subtracting like this, or if you were to place that in the denominator, you'd have to switch the order of your subtraction. Now, some things that, like I know Algebra 1 students have not covered this yet, but anytime we have a root here, where there'd be like in the example here, I've got it as a cube root. But what happens is we can write that out as a fractional power. And so what happens is that root goes in the denominator of the fraction. As we can see in our example here, the cube root of b is really b to the 1/3. Now we can add on to that. Let's say we have, instead of 1 over x in our exponent, we have y over x. No big deal. That x will still be the root, but that y value now stays as a power. We can see it in the example right over here. This 2 goes in for the root, and then the 5, right? The 5 is what stays in for that power. Now, one thing you should note here is anytime it's a square root, that means there's a 2 here, but we usually, since we deal with square roots so often, we don't bother with that. We just pretend that's an invisible 2 there. Okay. Also notice that this is the same thing as taking it all to the 5th power. Interesting piece here on exponents. If we're raising something to a negative power, that simply means do the reciprocal. So a over b becomes b over a. So if I had 3/4 to the -1 power, that means we really have 4/3. And same thing goes here, right? We can think about a negative power doing the reciprocal. That means it places b to the x in the denominator now. So b to the -7th becomes 1 over b to the 7th. These are the exponent rules that we're going to kind of go through and see what you all can do. But first off, some really quick, like maybe 5 seconds of problem. Just write down the answers. So for these questions here, take about 5 seconds and write down the answer for each one. Go. Okay. So let's see what it is. This one you should have as x to the 10th, because remember, whenever you're multiplying, you add the powers. This should have been x to the 24th, because a power raised to a power means you multiply. And this should be x to the second, because whenever we're dividing, should subtract the powers. Letter D would be x to the -2, which would then simplify to be 1 over x squared, right? Take that negative power, place it in the denominator. Oh, this is to the -1 power. So let's just do the reciprocal, 2/5. Over here, we see that y has a 4th root, so it's y to the 1/4. Over here, we have y to the 6th, but a 5th root of that. So it'll be y to the 6th, but then the 5 goes in the denominator because it's a 5th root. Next one, and make that power positive. This one, we're going to go the opposite way. We're going to take this. We see a 3 in the denominator, so it's a cube root, and it's y squared. Over here, we see a 4 in the denominator, so it's a 4th root, and it's y to the 5th. Okay, now, these ones are a little bit more involved, not much more. I want you to simplify these. And when you're done, we want no negative exponents or fractional exponents, okay? Go ahead and take like 10 seconds a question on this one. Okay, about 20 seconds left here. All right, let's take a look at this. On the first one, we see 4 times 6 is going to be 24. And then it'll be x to the 16th, because again, whenever we're multiplying, we add the powers. Now, letter B is kind of a tricky one. We're just adding here, right? So how many x to the 8ths are we adding? We're adding 4 plus 6. We're going to have 10 x to the 8th powers. Keep on going through here to letter C. I see 4 over 6, which reduces to be 2/3. And then again, when I'm subtracting, when I'm dividing, I should be subtracting the power. So it'd be x to the 0. And of course, we know everything to the 0 power is 1. So this is just 2/3. Probably a faster way is just to cancel out those x to the 8th, right? Because they're the same thing. Over here, we've got 2/6. So I'm going to reduce that to be 1/3. And then I kind of really like this canceling idea that I did over here. So if I look at these two, x to the 2nd and x to the 8th, yes, I could subtract those and get x to the -6 and then place it in the denominator so it becomes a positive power, which is our answer. But I think a quicker way to do this one is to, where are there more x's at? I think in the denominator, and I think there's 6 more of those. The only thing you got to be careful of is to make sure those exponents are always positive when you do that. Subtracting will never fail though, right? You can subtract those powers and get x to the -6 and then place that in the denominator to become positive. Letter E, We're just going to go ahead and place that x in the denominator. So it becomes a positive 8. Notice the 6 does not move. Many people think it does. Letter F, I see 12 over 4, which is really 3. And I am going to use this idea I had, which was who's got more y's? I think the denominator does. I think there's 6 more of them down there. Now the whole thing's at a -1 power, so let's just do the reciprocal. Really like that reciprocal idea with the -1 power. Okay, letter G, we have 4 over 24, which reduces to be 1/6. And then 16 minus 2 is 14. And again, every time you subtract the powers, always put that answer in the numerator. Letter H, we've got 15 over 3, which is a 5. And if I go the old way and subtract the powers, 4 minus 20 is -16, which I would need to make it positive by placing it in the denominator, right? Or you could have noticed at the very beginning that there are 16 more y's in the denominator than the numerator, and that's why that works out. Okay, let's look at some ACT type questions. Here's 3 of them. One where you're adding, and one where you're multiplying, and one where you are dividing. Everyone go ahead and take 15 seconds and do all 3 of these. Okay, I think on part A, the distractor would be that some people may try to multiply those powers or add them up. We don't do that. We're adding these things. We're taking 2x to the 5th plus another 2x to the 5th. Well, when I'm adding them up, I can easily see that 2 plus 2 is 4. So I should, get rid of those choices right off the bat. And it should be just x to the 5th, right? Because we're not going to change the power. It's not one of our rules. Now, letter B, on the other hand, we're multiplying, right? That's where you'll add the powers. And we can see we have 4 times 5 is 20. So I should get rid of those automatically, right? Now it's down to either J or K. And whenever you multiply, you have to add the powers up. So it's got to be letter K. Okay, next one. 6 over 2. That divides out to be a 3. So I should automatically get rid of those choices, right? Eliminate answers that are not correct. And then whenever we're dividing, we subtract the power. So 12 minus 3 is 9. We have letter C. Not too bad. Whoops. All right, let's try that again. Sorry about that. Gotta love technology sometimes. All right, where do we wind up at? We are right here. Oh, you gotta love this. Almost like we're back home. All right. Well, boy, you really don't want to end early. Let's let me try one more thing here. Let's go old school on this thing. All right, I finally have it fixed. There we go. Well worth the wait. Okay. Work out these three, please. Okay, test taking, we see that we have 2 times 2 is 4, so I should eliminate again those two choices. And when I'm multiplying, I add the powers up, so it should be 4 to the 10th. Over here on letter E, we are dividing, so 4 over 12 becomes 1/3, so I should get rid of the choices that do not have a 1/3 in them. And then I believe there are 4 more A's in the denominator than the numerator when I look at those by subtracting them. Must be letter E. And here we're adding some x to the 6th. We're going to have 9 of those x to the 6th. So letter F. Okay. The other type of thing that ACT will ask you is questions like this. What the value of x is to make this true? Well, this first one's not too bad because they both have the same base. They both have a 3, right? So since the 3 is equal to the 3, I think we could discern that that exponent should equal the other exponent, right? So if we add 1 to both sides, we're going to get a 14. And then if we divide by 4, we get 14 over 4, which reduces to be 7/2. That's what x would have to be. Now, this one, on the other hand, is not as nice. These are not the same number. We need to rewrite those so they are the same number. Now, 9 and 27, they both seem to be powers of a 3. Like 3 squared is the same thing as 9. So I'm going to replace the 9 with 3 squared. And then 27, that's the same thing as 3 to the 3rd. So I'm going to change that 27 to be 3 to the 3rd. Okay, that's our first bit. We're trying to make it look like the first problem that we had here. Now I notice I've got powers to powers, which means you multiply, right? So I'm going to multiply those, and I'll do the same thing up here also. Now it's just like the earlier problem. We have 3 equals 3, so therefore this exponent must equal the other exponent. So 4x minus 4 must equal 24 minus 3x. Well, we'll add 3x to both sides and get a 7x. Add 4 to both sides, we'll get a 28. Divide by 7, and we get 4. Okay. Well, in the interest of time here, I'm looking at my time. We're getting close to how much time I want to do with this. Let's look at some ACT questions that deal with these very similar exponent rules. Like number 33 here on the left. It's over what we were just talking about. Well, to multiply these, the bases must be the same. So we know that 2 to the 3rd is the same thing as 8, and 2 to the 2nd is the same thing as 4. So I'm going to rewrite this to be 2 to the 3rd squared times 2 squared to the 0.5. Okay, now power to power means we multiply. So we have 2 to the 6 times 2. Now 2 times 0.5 is 1. And when we multiply those out, we add the powers up and we have our answer. Okay, you do the remaining 3 here. These should be about 10 seconds each. And again, these are actual questions from the ACT. Okay. All right, we've got 4 other ACT questions, and then that will be it for us for today. Here, oops, this one's a little too big. Okay, I put in one difficult problem, right? It's number 54, it's exponents. And the other ones are pretty run-of-the-mill. Should be just like what we practiced. And 54 really wasn't that bad. And do remember, you can use your calculator, right? That's why you have it with you. Power to power, we multiply, right? 3 times 21, which will be 63. It's number 16 here again. We see a 3 in the denominator of the fraction. So we know it's a cube root, and the rest of it stays. And then here, when we're multiplying, we add the powers, right? But only have the same base. So the x's would be to a 9th, right? Because we have a x to the 4th and x to the 5th. Now notice that answer gets rid of 3 choices for me. And I notice in the remaining 2 choices, the z is the same in both. So I should just do the y next, right? Add those powers up. 3 and 3 is 6. All right. Well, hopefully you found this beneficial and helpful for you. Technology always is fun when I'm doing these. Have a good time. Enjoy yourselves and have a great week. Again, we have finals in just 3 weeks. Man, it's going quick.